the y-intercept is like a equals the mean of y minus b times the mean of x. And so I
Yes.
found the regression line where it's just like y hat equals 6.08 plus 1.707x, I think.
Do you need me to check that for part A?
Yeah, but I got it's like 1.707.
Okay, 1.707. Oops. Okay. Well, there are a set of equations here for the b and the slope. I have to look them up because almost no one does this by hand.
Yeah, exactly. But I have a feeling he's gonna put one of the like
Yes.
by hand ones on the test because he said it like in class.
Yeah, and that is common. Like they run out of things to ask you, so they move to this. So yeah, so you're just looking for an equation here because I don't have. I thought we were gonna run to the calculator first. Yeah. Okay, so okay, there it is. So your slope is the value of r times sy over sx. I think that's what you said.
Yeah.
So you take your value of r 0.596 and 9.07 over 5.36. And that looks about that. You said 1.07.
1.707.
That looks right to me. I can calculate if we need to, but to find the value of a, you take y bar and you subtract b times x bar.
Uh-huh.
Okay, and so your y bar is 9.07 minus the value you found in b, 1.707 times x bar, which is 1.75.
Uh-huh.
That looks about right. That looks
Okay.
good.
So I got that. I just have no idea what to do for B.
So they're asking you what happens when b is, I'm sorry, when your input goes up by 1.75.
Okay.
Okay, and you're like, what does that mean? Well, what affects the value of x in this? Sorry, which number affects x in this equation?
1.707.
Just the slope. So it's like asking, like, let's say x is 10, but then it goes up 1.75, so now it's 11.75.
Uh-huh.
Okay, well, what happens? Well, it goes up by the amount of the slope times 1.75.
Okay.
And that's it. It's not asking for anything more than that.
Oh. Okay. Okay.
It's just worded very confusingly to throw you
Yeah.
off, but it's really just saying, well, what happens if it goes up by
Okay.
1.75?
I think I got the important part out of that question right.
Yes, A is the important part, being able to use this information. But in statistics, more than other courses, you do have to sort of write a sentence every once in a while and interpret.
Yeah. Yeah. That's like literally all he doesn't even, yeah. Can we do 49, which refers to 47?
Sure. Let me go grab it.
I did 47.
Find r squared. Okay.
So I have the regression line for 47.
Yeah, so 49 is asking for our value of r squared. We'll start with that. So r squared comes from r, obviously. Do you have the value of r from 47? Yeah, it looks like it's 0.5. So r squared is 0.5 squared, or 0.25.
Is that all I have to do?
Well, then it moves to the part about usually they want you to write a sentence. Yeah, interpret. So here's the sentence goes like this. You insert your value for r squared, and I'll actually write this, but let me just give you the formula for it first. 0. Of, and then it's usually as a percent of the variation in y is caused by x. They're actually predicted by x, I think is what they use in the textbooks. So you would say 25%, because your number is 0.25 of the variation. So what are they measuring in problem 47?
The mean height, they're predicting the husband's height from the wife's height.
Okay, so 25% of the variation in men's height is predicted by women's height. So this, what I put above it is kind of your template, but the one below it is for this problem. You convert the value of r squared to a percentage, and you use the word variation, and it's not spelled real, but that is variation. And then you give the y variable, or the dependent. You can think of that as the dependent variable, and then the women's height is the independent variable.
So for finding r squared,
You literally just square r. There's
he
nothing.
gave us this like equation, which is like 1 minus
Sum of square error over sum of square regression.
Yeah.
Yeah, that's true too.
How do I do that?
You don't have the information in this problem to do that.
Okay.
So,
I need to find a question that
yeah.
helps me do that.
Did any of these have an ANOVA? It's okay if you don't know what that is, an ANOVA output with it.
There's a question that says,
so I can find one. I can pull up something for you if you want me to from this.
Are the output things where it's like predictor constant pairs and like
it's a table.
It's E and like coefficient S equals 9.46. Should I just send you what I'm looking at? Because you said something about the output, but like
let me pull something up there real quick that I think will help you immediately to understand this. Because it shouldn't be difficult, but it's like, why are there all these equations? And there just are. So let me pull something up here, show you. So what you're asking about is they would give you a table like this. It would be better formatted than this, but this first number is the sum of squares of the regression, and the second number is the sum of squares error.
Okay.
And
wait, what's the sum of okay,
analysis of variance is ANOVA. You may see that later in the course. They're doing your course in a weird order of topics. It's not, this is not the way it's taught in college.
Well, I was just asking, just ours is like SST, but I think I don't know.
That's the total.
Okay.
Which one is it? Is it sum of squares error of regression, or sum of squares regression over the total? Which one is it for?
It's the SSE over SST.
Okay. So your total, you would add these up, and again, it's kind of like another way to like get you to remember the formulas. They would probably give you the sum of squares regression, the error. You would have to add them up to get the sum of squares total, and then you could just divide to find the. But we shouldn't do this unless you've got one like that. But I think you just sent over something. Take a look.
Right, that's one of the like output things.
Let me go back and look. Nothing's come in yet, quite yet.
Oh.
But just another moment here.
I thought I sent it. Oh, it says failed to send.
Let me know if you need the email again to get it over to me.
Is it sending? It says it's sent now.
Okay. There it is. Got it.
All right.
Yeah, this is not quite the same as what I put up, but it's very similar. You can just read off the R squared value. You want your R squared value is right there.
Yeah.
And this is the condensed version of another table, but that's probably enough for the moment. You never want the adjusted one.
What is that?
I actually don't know when it's used. I've never used it. I mean, I wouldn't know. It's got some use, but the big thing about the R square value is that it's like, is it a good predictor or not? Like my dad was way taller than my mom, and that would be like supportive of this, like, because but some couples are the same height, and it's like only 25% of the time is this a good predictor. You know, like a woman's height, she might like someone who's taller than her or shorter than her, the same height as her. But there's other types of correlations where it's like, yeah, that's a really good predictor.
Mm.
And that's what we're going towards here.
Yeah. I think I'm doing fine with like finding the like regression line.
Okay.
That's not that difficult. And then like extrapolation. Okay, residuals are kind of, I just don't know. Like
So
I feel like some
there's another formula. Do you have the formula for residual?
it just says like the observed y, like y minus y hat.
Yes. And sometimes they ask you this, or in a multiple choice, they give you the minus and the plus of the answer. So just be consistent, kind of know these formulas. So the residual comes from after you have the regression line, you estimate
The points.
Yeah.
Like the difference in the points in the line.
Yes. But usually they pick a point. And the idea is to, just get another number, another calculation on the test. Because one residual by itself is not actually very useful. So is there a question with residuals? I mean, I'm looking at so like 47B, we could do a residual on that if you would like.
Yes, please.
Okay. So you said you had the regression equation for 47.
Yeah.
Okay. What is that?
It's y hat equals 33.67 plus 0.54x.
Okay. Actually, I'm sorry, we cannot find the residual but let's just say we had a data table, and well, I'll make that up in the moment, but we would evaluate at 67. So let's
Oh.
get that number. That's the first thing we do.
0.54 times less 69.8570.
Yes. So let's say, and I just made this up. Let's just say this is the data. Obviously, there's a lot of data missing, but when X is 67 in our data set, the Y value is 70. So what would
Okay.
so now that's where you can calculate the residual. You have to go back to your data table, find the 67 because that's your input, and use the Y that you got as the output. So your residual is 70 minus 69.85.
Oh.
And that's it. But you can only do it if you have a value in the data table. Like if you had 62 and 68, or 71 and 75, like none of those are helpful because you want the one that's your input. But they could ask you for the residual of any one of the inputs.
Okay. There's like for like residual plots.
Yes.
Yeah.
So that's where you would actually do that's where you would actually calculate the residual for each one.
So like,
so let me, do you want us to do that, sort of do one of those problems?
yeah,
Okay.
please.
Yes. All right. I'm looking at 54. How much
Okay.
of this are you going to do in your calculator, do you think, on the exam?
Probably all of it.
Probably all of it. Okay. Have you been using your calculator?
Yes.
Are you comfortable with it?
Not doing this.
Okay, so let me pull up a calculator. I've got an electronic one here that I'll be able to share, and we'll go through this. So while I'm doing that, can you tell me in 54 which is the input, or which is the independent and which is the dependent variable for this? Because we do need to know that before we can get going on this one. If you're not sure, I'll help, obviously, but
Okay.
so I'm actually gonna have to go down to D to give us the answer. It's the body mass is the input. Body mass is your X and rate is your Y.
I feel like I don't ever, unless it's like pretty much blatant. Like, how do I know that that is like from reading the question? How do I know?
It's not clear. In full
Okay.
disclosure, like this one doesn't tell you that. I mean, somewhere it will say like independent or dependent or something, depends on. I went down to letter D because they always give the input is the most common question. So
Yeah.
and they ask, what is our predicted metabolic rate? So predictions are on the Y given the X, but it should be more clear. This is a bad question. Do you have your calculator out?
Yeah.
Can you get it out? Okay, great.
Put
So
in the data points.
I'm gonna share my screen here, and this is an 83, but it's really similar. Why is that happening? All right, I need to restart that.
33.1. Because I have like the steps like written down. I just like I haven't done it before, and I don't.
Yeah, so I'll show you all the steps here, and then you'll have the you can go back and look. But the first thing is to enter the data. So you got to go to stat, and then you edit your lists. So generally, you put your data in your X in list 1, and
Yeah.
the most common mistake is to just not enter the data correctly. So just be really careful because there's really no partial credit.
Okay, I have all of that.
All right, let me get caught up to you here. And then how's are you currently active in softball, or is that
No, I can't play right now. I hurt my shoulder.
a bummer? That's
Yeah.
but if you don't take time to heal, you will be sidelined further, I guess.
Yeah, very true.
Okay, so I always quit out of this. I don't quite go to stuff. So the first thing I want to show you, and I know we're gonna get the regression line, but the first thing it's always good to do is to actually graph the data. So if you go to second y equals that stat plot, do you see how it's turned off by default?
Yeah, mine is.
You want to hit enter and turn it on.
Yes.
And you do that there. Now, if you're, I don't know if you're in between like math and physics or 2 math classes, but you definitely want to be you definitely want to be making sure of this stuff. So if you go right to graph, which you actually don't want to do usually because you may not have the right window, you can do a zoom stat to start out, but let's just graph it and see if it works. And like, there's nothing in this picture.
Yeah.
So I'm going to go to zoom and then go up to stat, zoom stat, and that gives me a better idea. Now, all this shows me is this stuff here, which is.
Whoa, mine looks different, kind of.
Okay, let's make
Oh,
sure.
not really. Mine's just squished a little bit more.
Okay, make sure we got the right, let's assume we got the right data. We're going to find that out here in a moment. Let's quit out of this and let's do a stat calc. And then you can either do 4, I always do 4 linreg. I know sometimes they want you to do the other linreg. Did your instructor mention
No, I think we just do the like 4 one.
4? Okay, so let's hit enter. Let's see if we get the same values, because that'll tell us if we're on the same track here. Do those match?
No.
Okay, so I'm going to go back to my list.
What did I put in wrong?
Well, that's the thing here. I might have put something in wrong. 995. I actually do have one wrong there. And this is the most common source of error, is just entering the data wrong. I would tell you on a test or a quiz to enter it or to look at it twice before you do any calculations. And then you'll know how you did. So I think I made the mistake here. 31. Just checking the other ones. 2, 4, 3.
Yeah, I think all mine are.
Yeah. So if I go back, if I quit out of this, if I do a zoom stat again, I bet our windows look really similar. Is this maybe what
Yeah.
Okay.
Yeah.
And then if I go back and I do this again, it's stat calc number 4. Hopefully we got the same equation. Is that what you're saying? Okay, so you want to write this down. Y equals and this one's, but we'll put the b value first. 201.16 plus 24.03.
Wait.
So make sure you have that written down, or I'm going to use it again. So the next thing we can do is we can actually calculate the residuals by going back to the list.
Wait, I write this down like as a regression line?
Yeah, I mean, I've wrote it down. I'll show you. But I would write that down if you can.
I do 24 point plus 2. Okay.
Okay, so we're going to next calculate the residual, and the residual is your y minus your y hat. Okay, actually, let me go back to the other screen so you can see what I'm going to do, and then I'll come back to the this. So right now, your X's, they're in L1 and your Y's are in L2.
Mm-hmm.
So we want to do this in we want to do Y minus Y hat in L3. So what we're going to do, we'll actually do this in a couple of steps here. We're going to first calculate the estimate. So I'll show you how to do that, and then we'll calculate Y minus Y hat here in the fourth column. Okay, so I'm going to go back to the other screen with the calculator, but just give you a sense of what we're doing. So go back to stat, edit, and then go over to L3.
And L3.
And then you want to go up to the top this time. And this time you're going to type in that equation 201.16 plus 24.03 times, this is where it's slightly awkward, it's kind of programmatic. You want to choose list L1, which is under second number 1.
Times L1. Okay.
And when you hit enter, populates that list.
Yeah.
Okay, and that's what we talked about doing. The formula goes away, so that's why it's so important. I mean, this calculator is not, it's old, very old. I mean, technology is really old in it. L4, we want to do the residual. So the residual is Y, which is in list 2. So we want to grab list 2, and we want to subtract what's in list 3. L2 minus L3.
It's L3. So I got negative. Okay.
You hit enter and it populates that list.
Yeah.
Okay.
And these are the residuals.
Those are the residuals.
And then I can graph.
And now to graph the residuals, you got to be a little bit, you got to be comfortable with this, but you go back to stat plot.
The X.
And we want to change the Y list because that's what we want to, we're interested in, to L4 now. Yeah.
Zoom. Stat plot.
Zoom.
Whoa. Okay, yeah, that's what mine looks like.
Yeah, and so they should be kind of all over the place like that.
Okay.
Now there's other statistical tests you can do to learn something about the residuals or make a statement about them, but we're not going to.
I can go to list for the residuals L4 to find standard deviation.
Well, of the residuals.
Yeah.
Sure, you can do a one variable stats on list 4 if you need to. That'll give you the standard deviation.
Okay, I did that. That was just like the next thing in my notes. So I was trying to figure out if I knew how to do that.
Yes. It would be good for you to do that, on your own with maybe a data set from class, just to practice, entering data, work manipulating the lists. It's not difficult, but it's different than what you're used to.
For like correlation, which was like way before this.
Yeah, I mean, correlation is your R value.
Where's the formula that how do you find this is just the regular like linear regression thing?
Yeah. Now there is a formula for R. It's quite horrific when you see it for the first time.
Yeah, it's really like the 1 over n minus 1.
Yeah, there's a lot there.
It's the average of the products of the z-scores for each individual. Yikes.
That's one of them. Yeah, the one that I'm trying to find one here. I mean, you've got some sigmas of you got a you have x times y, x squared, some of the x's squared. There's a lot there.
I
It's
don't have to do that though. I don't think.
that's good. I would want to know that though, heading into the exam. I don't want to know, okay, do I but yeah, I mean you equation for regression R. So where should we go from here? We got some time left. What else can we look at? What other questions do you have?
I feel like I just like don't know what type of questions are gonna be on the test.
So
Like
when is your test? Is it tomorrow?
it's Wednesday.
Wednesday. Okay. So you're going to get some sort of, regression equation using the regression equation.
Uh-huh.
Some calculations like we did.
Uh-huh.
But a common one is that R squared, like writing an interpret statement.
Yeah.
They almost always give you on a correlation versus causation.
Yeah. I can assume that something is causing something. Yeah.
So it's almost impossible to ever say that one thing causes another.
Yeah.
You can only say that they're correlated.
Yeah.
But they're looking for, they're asking about that. There's usually an interpolation versus extrapolation. So there's some instructors that, and I think this is the general consensus, is that you're not allowed to extrapolate outside your data set.
Yes.
But we actually do this all the time in real life. So it's kind of backwards, but in terms of like your class, you're not supposed to. So they usually ask you a question where they ask you to interpolate, but the values outside of your inputs, and
What's interpolate?
when it's inside the inputs.
Oh, okay.
And like let's say you're looking at ages of people from like 10 to 20 years old. Okay. And then they want you, so an interpolate would be anything from 10 to 20.
Yeah, it's just the opposite of.
Yeah,
Okay.
but extrapolation would be any, like if they gave you someone who's 9 years old, or they ask you like about someone who's 21 years old, they're outside of the input, so
Yeah.
you can't use it. Using they maybe ask you to make a scatter plot.
Yeah, he's definitely asked me to do that.
They'll ask you to write the equation, use the equation, interpret the equation.
There's an equation.
The regression equation.
Oh, okay.
Yeah, you'll have to do that. You've already taken a test. So what do you remember from that test in terms of like, was it like a standard test that was pulled from, a book or website, or was it something handmade, or, how closely did it match the questions from class?
It was actually nothing. The last test was like pretty simple. So like I don't think this will have any like crazy like over the top thinking questions. I just think I'll have to understand like how to find the regression line, how to find like interpret R squared, or like figure out R from like looking at a little graph, and like the association and the direction and the form and the strength and the.
Oh, there's a good one. The direction and strength. But what I was trying to get at, and we'll talk about that in a moment, is like part of when you go to college is like, you really want to figure out what their style is, so you know what to expect after the first test. Like the first test tells you, okay, the questions are just like the book, or they're not at all like the book, or something like that. And that's what I'm trying to get at, is like maybe you get a feel for like what they were emphasizing. in class. Here's a question for you. If r squared equals 0.9, and this is the regression equation, okay, let's just say that's the regression equation. What is the value of r?
Of, oh. If r squared is 0.9,
Yes.
I don't know what to do. Other than
Well,
r is just the square root of, like, I don't know.
so this takes you back to a previous class. When you take a square root, it's plus or minus, right?
Yeah, so it's plus or minus like point, whatever it is.
Yeah. So whatever it is now,
3
how
point.
do we decide is the question. And to answer that, that's why I gave you the equation of the regression line.
Because of like this. Like,
This line goes down, so your r has to be minus
yeah,
0.95. So that's kind of a test question they like where
0.95.
yes. You're
That's the
welcome.
square root of 0.9.
Yes, you're welcome to check that with the calculator. The square
Oh,
roots, when
I
numbers are
just
less than
didn't.
0, less than 1, the square roots are bigger. It's kind of odd because they're usually smaller.
Yeah, that was weird. Okay. I get that now. Yeah, the line 1 minus starts at 1. There's a slope of yeah. Okay.
That's a style of question. Your instructor may have given you some guidelines like 0.3 to 0.7 is moderate in terms of
Yeah.
its strength. And that's sort of arbitrary, but 0.7 to to 1 is strong,
Yeah.
and then everything else is weak. Another question they sometimes like to ask is like, which of the following has the strongest correlation? So it'd be like minus 0.97, 0, 0.1, and 0.75. Which is the strongest correlation of these?
Strongest core A.
A. So it doesn't matter that it's negative. It's the one that's closest to 1.
Yeah.
Sometimes they ask you questions like, can the correlation ever be greater than 1? No. A lot of times they give you graphs and they're like, is this positive or negative correlation? Well, it's obviously positive.
Yeah.
But where it's harder is when it's sort of all over the place.
Yeah.
And I don't know if they cover this, but when it's this bad, usually you just use y bar as your regression line. Did that maybe come up in class?
No, I don't think he's gonna give us one like that because he
Okay.
didn't ever.
Okay. So you got,
He just kind of said it's like 0 when it's like that.
yeah, it's the slope is 0, not the actual regression line.
Yeah, no, he said like r equals 0.
Yes, r equals 0 here. And so there's some questions there, like interpret, what does that mean? You got to kind of be comfortable writing out a few sentences on that. Okay, so like for example, we didn't look at 20, but there's a question at the end of 20, which I'll snip in here. It says, does the data show that taller women tend to date taller men? And this is the kind of question where you can't draw on your personal experience. You have to literally like use the regression equation. Like, does it support that?
Yeah.
And like sometimes they do, sometimes they pick examples like hours studying and your grade on the test, or hours of TV watching and your grade on the test. They sometimes try to pick ones that there is some intuition built in, but they're expecting you to be able to, write a sentence or two for it. They sometimes also ask you, did you talk about confounding variables?
No.
Okay. we'll move on from that. Prediction. Let's see here. Calculate the regression, explain. So you need to be able to explain the slope. Slope is rise over run, but it's got the units of y. And that's what they're really looking for, the units of y over the units of x. Sometimes they want that in their predicted value. Which point has the largest residual? So that would be, you would have to actually calculate all the residuals and figure out which is the furthest from zero, not necessarily the most positive and most negative.
Okay.
And that's it. I mean, I just went through all your questions. I was looking for the ones that are just outside of just find the equation or graph it or something.
I think I am doing like I think I understand this sort of.
Yeah, I mean, this is not a complicated section of the course. It does get more difficult, but
yeah,
we're not there yet. Here's another one of those, like explain what this value means. So they're talking about R. So how would you describe R? There's two words they're looking for.
There's two words.
So weak, moderate, strong, negative, negative, positive.
So this is like there's a strong correlation and a positive.
So you would actually just combine them, strong, positive.
Yeah. Well,
correlation. Okay. And if we were to calculate R squared, we should do that real quick. I know it's not a complicated one, but we should get that value. So that's, so I'll say about 0.74. So R squared is that means 74% of the variation. And then we have to determine, well, which is the input, which is the output. Let me go back and look. This was from question 22. So the brain weight is your Y. Your brain weight, 7% of the variation of your brain weight is predicted by body weight. And that may be a, that again, like I think you're going to get a question where you have to interpret R squared. I mean, that's a pretty common thing that they ask for in this course.
Yeah, yeah. Yeah, he gave us like a interpretation thing where it's like about whatever, like 74% of the variation in the Y variable is accounted for by the linear model relation Y variable to X variable. So yeah, he's definitely gonna ask us about that. But I think I'm good.
Yeah, I think you are too. Could hear that you're just maybe a little exhausted tonight, but thank you for scheduling. If you ever need a time that's like something a little earlier, just have your mom communicate with me. I have some open time sometimes that I have in my schedule. If this is too late, so.
Okay.
But I think you're all set. The course does get more difficult, so just keep that in mind. You may find you do need a little bit more help, but glad to help you and good luck. I think you'll do great.
Thank you.
You're welcome. Have a great night. Bye now.
Bye, you too.